Welcome to 6502 Emulator in Python Part 14. We are getting up there. So in today's video, we're going to take a look at some viewer suggestions. I've gotten a few suggestions from a couple different viewers, some suggestions on refactoring the code, and some issue raised were missing flags. And that's actually what I'm going to actually start working on today, is setting the negative and the zero flags. And so you'll see what these people wrote on to my GitHub, and we'll take a look at some of that, and then we'll implement at least some of that today, but not all of it, because only so much time in the day. So anyway, let's take a look. We are working on our 6502 emulator. So I'm going to go back to here. And basically what we're trying to implement is flags. So we talked about that earlier in the series. There are these flags in the CPU. So you got the negative, overflow, zero, and carry flags. Now, as I've been coding, I think I've been setting the carry flag correctly. So for the commands that need that. But today what we're going to do is we're going to be working on the N, which is the negative flag, and the Z, which is the zero flag. We're going to skip overflow for now. I think there's only 3 commands that use that, and that's a bit more complicated, so we'll come back to that some other time. So I'm just going to go down through and code wherever I see N and Z. But let's take a look at, sorry, I should have had this open. I'm not sure why I closed it, but here you go. So this is the GitHub. And you'll see here I have issues. So this is where username Ray Bellis. So thanks to Ray from England, which is very awesome. So thanks to Ray for taking a look and taking the time to read this and watch and make some suggestions. And also Garib85 talked about the LDA command, and actually it applies to all the commands. Let's take a look real quick at what Ray wrote. So Ray wrote about how I can massively simplify my code, and he talked about certain things here. And I think, he's absolutely correct, especially here with this read and read 16, because basically what I have here is something that we don't like to have, which is, let me just go down here somewhere, is we have a bunch of, where's that at? We have a bunch of repeated code here. So you see this LSB, MSB, loc. You just don't want that. So, he recommends like rewriting that as a separate function, and he's absolutely correct. I will do that at some point. So he has read, which is going to read an 8-bit memory location, read 16, which will read a 2-byte memory location. So that's great. He has write, and this is good because it deals with values outside the proper range. I don't have any checking for that, at least very little here and there. So yeah, he has a lot of really good ideas here, and I will implement some of those later. He talks about different ways to do the program counter incrementing, and I'm not 100% sure I'm going to make that change. I did it a different way. I think it's okay, but I'm sure his version is much better. Yeah, so we're going to look at that. Well, I'm not going to do that today, but that's one piece of feedback which I thought was really good. So thank you again, Ray. And then the second one, this is one where I'm actually going to use today. So again, he talks about wrapping here and just different ways to do it. He thinks the branch functions are off. I think they're okay. It's just the way, I think it's just implemented a little bit differently. So I think even here he says, it looks like your branch extensions are actually okay, but only because of the use of increments. Again, if I hadn't used increments, there's different ways to do things. But as he mentions here properly, I don't make sure that any of my branches or anything are in the proper range of 0 to FFFF, which is 65,535. So again, thanks, Ray. Where's the thing you wrote? Or was the other person here? Let's take a look here. And then this one says here, he says that, it's here. So thanks, Ray. So Garib85 says LDA is missing set flags Z and N, and he's correct. That's what we're going to do today. I'm not setting any flags except for carry here and there. But so Ray says, yeah, when you do fix this, note that several other instructions, LDX, maybe I should make that bigger, LDX and LDY have the same behavior. So he recommends the set NZ, self reg, and self.z equals reg equals 0, self.n equals bool reg and 0x80. So That's a new one. I don't actually know what that means. So I'm probably going to have to look that one up. So he says, yeah, your functions have a similar bug. They do not set Z. In fact, all of your load instructions are missing N and Z. I know that. You know, if you go back to the start page, I have that listed down here in to be implemented setting flags. So let's go ahead and take a look again at Ray's code. I think I'm just going to use that instead of writing my own, because you know what? Somebody did it for me. So again, thanks again, Ray. And anything else, I'm just going to copy it. What the heck? I'm going to copy it and give it a shot. So we're basically, what we're doing is we're setting the negative and 0 flags based on the value of some. Now he has register here, but I think it also applies to not just registers, but I think it applies to memory locations as well. So I'm just going to change that because just to keep it consistent with the rest of my code. So I'm going to go back to here, and I am just going to plop that in here and down with the rest of the kind of the helper code, I think. Or is that up at the top? Let's see here. Where we throw that in here? Where do we have wrap at? Okay, so we'll put it in here. Okay, we'll put it here before all these other things. It's got to go in that order anyway. So I'm going to go ahead and copy that. That was dumb. Tab that over. Alrighty. So I'm going to change this to value because I don't want to use reg. I'm going to change that to value just to keep it consistent with what I wrote up here. And value. And I'm actually going to Google real quick. I don't know. I'm not familiar with that. Say bool command in Python. I have an idea, but we'll see what happens. Convert value of Boolean. Let's see values. Well, you know what? I'm just going to trust Ray and see how it goes. I have some testing code. We'll see what happens. If it doesn't, I'll fix it later. Okay, so what this is supposed to do is if the value is 0, then Z is going to be set to true. If the value is not 0, Z will be set to false. Now again, for my students, if any of my students are watching this, this is just a nice short way of doing if value equals 0, self.z equals true, capitals, true. And then else, self.z equals false. But this will do the exact same things. This is just a nice little shorthand way of doing things. And I'm presuming that this will do the same thing. And the reason that negative, he's, anding the value with 0x80. 0x80 is 128, so that is our leftmost bit. 000, 000. Oops. One more. And I've explained this, I think, in a different video. So if this bet is set to 1, it is considered negative. So that gives us a range, I think, of negative 127. No, negative 127 yet. Negative 128 to 127 or something like that. I forget which video it was in, but we talked about that. So basically, we're just checking to see if the value is 0 or not, and if the leftmost bit is set. So I'm gonna trust Ray that this code is correct, because I haven't seen this before. I did something similar in a different video, but I had to do an if statement. So this is how I'm learning too. So that's pretty exciting. So I really do appreciate that. So what I'm gonna have to do is, I think most of the commands are in the same order. I hope. No, they're not in the same order. So what I'm gonna do is I'm gonna go through. I'm going to go ahead and open this up. I'm going to go here, and I'm just going to scroll down through. This probably was going to get boring for you. But so we see add with carry, and we do set the N and Z flags. So I'm going to go ahead and do add carry. So again, there is a value. Add the value to the accumulator. So, and then we're going to do set nz, and so I'm going to do self.set nz, and it's going to be self, and it's going to be self.a, because it's the value of the accumulator that is working. Actually, before I do that, I want to actually test this. So I did some testing code for LDA, Okay, so I'm going to go ahead and just plop that in there. And so what I did was basically I'm going to LDA the value of 0, 0. So this should set the 0 flag because the value is 0. So let's go ahead and run it. Oops, are we not running again? Yep. Close that for you. And do that again. There we go. Save and run. Self set NZ takes 2 positional arguments, but only one, of course. 230 LDA self set NZ. It's not necessary. That is from doing too much Java, I believe. There we go. So the accumulator is 0, so the 0 flag is set to 1. So that I'm with that so far. So that looks like it's working. Let's set it to 1. So the 0 flag should be set to false. So this is 1. The 0 flag is set to false. So far, so good. So let's set it to the first negative value, which is 0, 80. And compile it, or not compile it, we'll run it. Yeah, it keeps locking up like that. It's really annoying. I think it only does this when I have OBS running. We'll live with it. So we have 128, and that gives us the 1, which is negative. So I'm pretty happy with that. I'm just going to test one more value, FF, because I know the leftmost bit is set. FF, so let's try that. And we have the negative. So now it's not possible to have negative and 0 at the same time for obvious reasons. But yeah, I'm pretty confident that this is correct. So that is good news. So I'm going to go back to here. I'm going to copy that out. And I'm going to go to ADC because that has N and Z. Again, I've already set the carry, so I don't have to worry about that. Overflow we'll do another day. So I'm going to set this properly. So really now all I have to do is go through and copy and paste this everywhere where N and Z are set. So this is probably going to get very boring for you. So this will be and. I'm going to go ahead and set that. And we got A, S, and L. So this is also N and Z. Ooh, actually, you know what? I got to think about what I'm doing. I got a little overconfident. So right now what I'm copying is add carry. So this is with the accumulator. So I got to be careful. This is also accumulator. And arithmetic shift left does not always do the accumulator. Okay, this is good. And does not always do the accumulator. Add with carry doesn't always do accumulator. Alrighty, awesome. Okay, so I do need to make some changes here. So this is a good learning experience. So I'm going to go back with add with carry. So add carry. Actually, no, it does add to the accumulator. Sorry about that. Bitwise and with accumulator. So this is okay, but AS and L. Okay. It depends. If it's accumulator mode, then the value equals self dot A. Okay, so all I need to do is update that there. So I'm going to go ahead and do that. Instead of self.a, I'm going to do value because it might not go into the accumulator. So what happens here is if it's the accumulator, self.a goes into the value. Then we do all this blah, blah, blah stuff. And then this is where I could have done bool, just, bool, blah, blah, blah. Check the leftmost bit, shift, blah, blah, blah. But anyway, value is going to hold that value. Now, if it's accumulator mode, we put that value into A. If it's not accumulator mode, we put that into the memory location. So what I can do here is put value. So that's going to work for that, I presume. Next is BCC. So, actually no, ASL. ASL. I just did ASL, right? Yeah. So the next one should be, I didn't do bit yet. See, branch instructions don't affect that. Break affects B. We haven't done break yet either. So let's go to compare. CMP. Did I not do compare? Oh, there it is. Okay, thank God. So compare to accumulator. And so then this is also going to be accumulator. So we're going to go ahead and paste that. Set NZ. And it's going to be self.a. Alrighty. And so CMP, compare X. All right. So this is what Ray was talking about. So if we're doing X, the X register, so CPX, did I not do? Yeah, I think I missed that one. Yeah, I missed CPX. That's not good. Okay. I'm just going to make a note of that for now. And I'm going to go back to, I'm just going to go here, just right. Okay. CP to do CPX. Come on. Probably CPY. This is good. This is a good exercise. CP, yeah, I forgot to do this. CPY, DEC, I think I did that one. DE, nope. How did I miss all these? What happens when you talk and don't listen? Decrement memory, DEC. God, tell me I did this one. E or Yosh. All right, so we E or with the accumulator. So this is going to be accumulator. Set NZ for the accumulator. Self.a. Okay, we already done clear carry and all this kind of stuff, so we don't have to worry about that. Increment. I didn't do this one either. Jeez, oh man. All right, well, I mean, they're going to be easy to do because they're just basically copies of other stuff, but yeah, well, did miss a few. Did feel too easy. Jump, no flags affected. JSR, no flags affected. LDA, I think that was the first one we did, but let me just make sure. Yeah, LDA, set NZ, self A, good. LDX, there we go. This will make Ray happy. That's what he was talking about. So this should be self.x. Oops. LDY. So that should be self.y. Okay, now we're back to LSR. And this is going to be similar to ASL. So it's going to be the value. So down here, we're just going to go ahead and do value. Because again, that value may go into the accumulator, it may go into a memory location. Again, as Ray mentioned, he had an idea of, instead of doing it like this, do a function to do that, which is a great idea. That was a good idea for refactoring. Wraparound, I'm going to skip that for now. We're going to go ahead, no operation, no flags. ORA is bitwise with accumulator. So, oops. So that's self.a. Oh, TAX, I didn't realize those were going to affect that. So TAX. So transfer the accumulator to X. So just to make it, so the value of X, this is going to be TXA. This should be self.a. TAY should be self.y. TYA should be self.a. All right. Yeah, I can't believe I didn't do this. Annex, etc. DEY, didn't do those. Did I? Oh, I did do DEX and DEY. All right, awesome. DEX. So it should be X, DEY. So Y. X. dx, dey, inx. Okay. Should be x,iny should be y. And yeah, I think I did all those. All right, I think we're good there. Dx, dy, yep. Tx, ty. All right, I'm pretty happy with that. We gotta go to ROL. Again, if I missed something, please comment. Man, I'm doing this kind of fast. So again, ROL is just like we saw earlier, because it may go to the accumulator, it may go into memory. So this is just going to be the value. And ROL, ROR makes sense. Same thing. Our value. Yeah. RTI, we haven't done interrupts yet. That's definitely on the list. Done RTS, but no flags affected. Subtract with carry, SBC. So this is subtracting again. Subtraction operates on the accumulator. So that's going to be self.a. Store accumulator. So does not affect any flags, which is interesting because we only affect flags when there's a change to the value, in this case the accumulator. But since we're storing, that doesn't change. Stack instructions do not affect. Looks like they do not affect. Well, instructions apply length. So transfer x to stack pointer. So x doesn't change, but transfer stack pointer to x. Push accumulator, pull accumulator. That doesn't say anything about affecting the. It doesn't say anything about affecting the flags. Let me just check the other one. So TXS, control find TXS. Transfer stack pointer to TSX. Transfer stack pointer to X. And you see here it does say N and 0 are affected. So I'm going to go ahead and trust this. It just makes sense. So you see here, transfer X to stack register doesn't affect these. But transferring stack pointer to X does affect those. So I'm gonna assume that I'm correct. So transfer stack pointer to X. I'm gonna say TSX. And so anytime there's a change to one of those registers, we have to update the flags. Push accumulator and pull accumulator. So control find PHA. Push accumulator. So push accumulator doesn't change it because the accumulator doesn't change, but pull accumulator. So accumulator does change, so we do need to do that. So PLA. So I'm gonna go back to here. So PLA, pull accumulator. And we got push processor status and pull processor status. Now, just by definition, that it's going to affect the processor status, but we've already taken care of that. Okay, store X, no flags. Store Y, no flags. And we're at the bottom. Oh my gosh. Okay, so again, I could go through and just test all this, but you know what I'm going to do? I'm going to assume that's correct. And compile it to make sure there's no compilation errors. I'm going to run this and make sure, see if that's running. So 255 gives us a negative and non-zero. So since we copy and pasted, we'll assume that everything is working as expected. So yeah, that was pretty quick, quicker than I thought it was going to be. But let's go back to the coding concepts. So again, thank you to viewer suggestions. Was it Ray and Garib 85. So I have set the Z and N flags as far as I know for almost everything. And then Ray, again, thank you. I used your code. Just made a slight change because it's not always a register. So because it could be a memory location or a value. And so your rotation functions do have a similar bug that sets Z. I think the rotation functions are similar. I think the rotation functions are okay. Or did I just do those? ROR. I just did those. So ROL and ROR. So yeah, So I think we're okay with that now. Again, I would need to do proper testing to make sure. Oh, sorry, I was looking at the code there. I think we would need to do proper testing if that were the case. But again, I'm going to call this a win. So again, thanks to Garib. Thank you to Ray. I appreciate your help. Ray, I will get to some of the other refactoring suggestions you made later. But for now, I think we're going to call this a night. I got a big day tomorrow. Everyone, thanks for watching. And as I love to say, keep on coding. Take care.